Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm your host, Victor, and with me, as always, is the brilliant Sheila. Today, we're diving into a crucial aspect of operating systems, the system boot process.
That's right, Victor. We're exploring section 2.10, titled System Boot, which is the final section of Chapter 2 on operating system structures. This topic is fascinating because it's something that happens every time we turn on our computers, yet many of us don't fully understand what's going on behind the scenes.
Absolutely, Sheila. Before we dive in, let's quickly cover some fundamental terms. The boot process is the sequence of operations that happens from the moment you press the power button until your operating system is up and running. Key players in this process include the BIOS, or UEFI, the bootloader, and the kernel.
Great introduction, Victor. You know, I like to think of the boot process as similar to starting a car. Just as a car needs a specific sequence of events to start, so does a computer. Shall we walk through this process?
That's a fantastic analogy, Sheila. Let's do it. When you first turn on your computer, it's like inserting the key into the ignition. The first thing that happens is the computer's firmware, either BIOS, Basic Input-Output System, or the more modern UEFI, Unified Extensible Firmware Interface, springs into action.
Exactly. The BIOS or UEFI is like the car's starter motor. It performs a power-on self-test post to check that all the hardware components are functioning correctly. This is similar to how a car checks its systems before fully starting up.
Once the post is complete, the next step is to find a bootable device. This could be a hard drive, SSD, USB drive, or even a network location. The firmware looks for a special program called a bootloader in a predefined location on the bootable device.
That's right, Victor. The bootloader is a bit like the car's fuel injection system. Its job is to load the operating system kernel into memory and hand over control to it. One of the most common bootloaders for Linux systems is GRUB, Grand Unified Bootloader.
Great point, Sheila. It's worth noting that the process can differ slightly between BIOS and UEFI systems. BIOS is older and has some limitations, such as only being able to boot from drives with a master boot record (MBR) partition scheme. UEFI, on the other hand, is more modern and flexible, supporting larger hard drives and providing a more secure boot process.
Absolutely, Victor. Once the bootloader has done its job, the kernel takes over. This is like when the car's engine fully starts running. The kernel initializes hardware, mounts the root file system, and starts the first user space process, usually called init in Unix-like systems.
That's a crucial point, Sheila. The init process is responsible for bringing the system to a usable state. It starts various system services, sets up networking, and eventually launches the user interface, whether that's a command line prompt or a graphical desktop environment.
Indeed, Victor. And just like how modern cars have sophisticated onboard computers that continually monitor and adjust various systems, modern operating systems have various mechanisms to manage and optimize system performance after boot.
Excellent comparison, Sheila. Now, for our listeners who might be preparing for interviews, it's important to understand the key steps of the boot process: firmware initialization, bootloader execution, kernel loading, and system initialization. Being able to explain these steps and their purposes can demonstrate a solid understanding of operating system fundamentals.
Absolutely, Victor. It's also worth mentioning that understanding the boot process can be crucial for troubleshooting. Many system problems can occur during boot, and knowing the stages can help identify where things might be going wrong.
Great point, Sheila. As we wrap up this episode, let's quickly recap the main points we've covered. We've discussed the boot process, including the roles of BIOS and UEFI, the bootloader, and the kernel. We've also touched on the differences between BIOS and UEFI, and the importance of the init process in bringing the system to a usable state.
Excellent summary, Victor. And as this is the last section of Chapter 2, let's briefly recap what we've covered in this chapter. We've explored operating system services, user interfaces, system calls, system programs, OS design and implementation, OS structure, debugging, generation, and now, the boot process. This chapter has given us a comprehensive overview of the structures and fundamental concepts that make up an operating system.
Thank you, Sheila, for that excellent chapter summary. And thank you, listeners, for joining us for another episode of Operating Systems Crashcast. We hope you've enjoyed our deep dive into the system boot process. Stay tuned for our next episode where we'll be starting a new exciting chapter.